So today is March 22nd, 2011. You guys copy this in your blue notebook, page 150. It's from your textbook, the two definitions. These are the steps to graphing a quadratic equation. Make sure you have these down. That's step 1. Step 2. Step 3. And step 4. Okay, so example 1, they've given us this equation, guys. They want us to find the zeros, or the X-Intercepts, as they're called. So we want the zeros, the axis of symmetry, the coordinate of the vertex, the maximum and the minimum, and the Y-intercept. That's a lot of different things they want. We're going to go through all of these right now. In order to find our X-intercepts, we know from looking at step 1 is we have to factor it. I can't factor this yet. I need to put it into standard form, which means I have to set one side of the equation equal to 0. So that means in this instance, I need to move this -3 to the other side of the equation. When I do that, x squared minus 8x plus 12 plus 3 equals 0. This is now in standard form. Okay? Standard form means we've set the equation equal to 0. Now that I'm in standard form, I can factor this. This is all, the factoring goes from our last chapter. Okay? So luckily this is an easy one. Factors of 1 are 1 and 1. Factors of 15 are 1, 15, 3, and 5. Okay? We know that it needs to equal our -8 in the end. I have to use this column because it's the only one there is, which means the factored form of this is going to have an x and an x. We just have to find out what the other numbers are. So, yeah, it's pretty easy to look at this one. I can tell right away that it's going to be 3 and 5, 1 times 3, 1 times 5, okay? And there is a combination of that to get to -8 if they're both negative. And if they're both negative, negative times a negative equals our positive 15, so that works. And if they're both negative, when they add up together, we get -8. Okay. So, now that I have that, pretty simple. I'm about to plug it in, -3 and -5. Okay? That's great. So, now what I have is my factored form. So I went from standard form to factored form, but I'm still not done. I don't know what the zeros are yet. I don't know what the X-intercepts, same thing. I don't know what they are yet. I need to set each of these brackets equal to 0. So we're going to set this one to 0. X minus 3 equals 0. And we're going to set this one to 0. So I have two different equations right now. X minus 5 equals 0, and x minus 3 equals 0. I can drop the brackets. X minus 3 is 0. X minus 5 is 0. And when I bring the numbers to the other side, this is 3, and x is 5. Great. So these are my zeros that we were talking about in step 1, or the X-intercepts, okay? So what I'm going to do is I'm going to graph this on the other page. So we're going to keep moving back and forth through the pages. So one page will be all of our work. One page will be us connecting it to the graph. So let's go to this next page here. So on the other page, we found that our X-intercepts, let's write it in red. Were x equals 5. And x equals 3. So what that means is I go to the x-axis on this graph, positive 3, and positive 5. I know that those are going to be the two x-intercepts. There's two of them in this case. So I'm going to have some parabola Maybe it's going upwards like this. Maybe it's going downwards like this. But it's going to cross the x-axis at those 2 points there. Okay? So that's the very first step. Now I got to go over to the second step. Step 2. Step 2, it says that we need to find the axis of symmetry. So axis of symmetry. Okay? So we had our equation. Remember, this is the equation we're using. We're using x1 plus x2 divided by 2. Okay? That's going to give us the value we want. So our x1, we found our x1 and our x2 in the previous step. Those were our 2 answers, our x-intercepts. So our x-intercept was positive 3 and positive 5. Doesn't matter which one I call 1 and 2. Just be consistent when you do it, okay? So in this case, we're going to call x1 our 3 and x2 our 5. Okay? This one's pretty simple. We just plug it in. This becomes 3 plus 5 divided by 2. 8 divided by 2 equals 4. Okay? So 4 is my axis of symmetry. And at the end of that step, I told you guys to represent it as an equation. So the actual answer for the axis of symmetry, we're going to do it in, red. The axis of symmetry, I'm going to put your answer here, is going to be x equals 4. That's how you write this answer. Because the axis of symmetry is a horizontal line, this is the equation for it, x equals 4. I'm going to show you what that looks like on the graph. So we have our axis of symmetry is x equals 4. Put that up here, axis of symmetry. We know that is x equals 4. So what that means is we have a line right on 4 that goes straight up and down. That's our axis of symmetry. So that's going to be the middle of our parabola. If we were to flip the parabola from left to right, we get the exact same image. That's why it's called the axis of symmetry. It's like putting a mirror in the middle of your face. Okay, you're going to get the exact same image on both sides. Okay, so we have our axis of symmetry. We graphed it. Step 3, we said we want to find the vertex and the max and min. Okay, so there's 2 things we're finding in this one. The vertex is already half bound for us. A vertex, we need an actual coordinate. So I'm going to need an x coordinate and a y coordinate for my vertex. I already have the x coordinate. The x coordinate has to be on the axis of symmetry. So because we found the axis of symmetry in step 2 was 4, I plug that value in for the x coordinate. Okay? So I already have half of this coordinate. I have to solve for the other half. In step 3, we said we take that x value and we plug it in either to the standard form of the equation or the factored form. So that means I actually have to go all the way up to step 1 and find out what my standard form was and what my factored form was. Either one. You only have to choose one of them, guys, but choose one, it'll get the same answer. I'm going to show you how that works. So if we go all the way back up here, our standard form was like this. X squared minus 8x plus 15. So I'm going to bring that down here. Oops. X squared. Did I say minus 8x, guys? Yeah. Minus 8x plus 15. That was our standard form. Okay? So, I'll do it in standard form first, then I'm going to do it in our factored form to show that we get the same answer. So, we take this x value of 4, and I plug it in for all of the x's in our equation. So, our next line is going to say 4 squared minus 8 times 4 plus 15. And don't forget, sorry, our f at x at the front of the equation. So, as I carry this out, I get 16, subtract 32, plus 15. That's going to give me f at x equals 31, subtract 32, negative 1. Okay? So in my standard form, I found that my y-coordinate, remember I said this is the y-coordinate for our vertex. I'm going to plug it in there. It's going to be negative 1. But let's check. I'm going to check using my factored form just to show you guys that I should get the exact same answer either way. Our factored form, if we go back up to equation 1 again, x minus 3 and x minus 5. This was our factored form right here. X minus 3, x minus 5. So we'll extend this a little. Our factored form, f at x equals x minus 3, x minus 5. Okay? Like we said before, we still have to plug in our value of 4 in for both x values. So this will become 4 subtract 3 times 4 subtract 5. This becomes 1 multiplied by negative 1, negative 1. Found the exact same answer, so there's no difference here. I'm going to find the exact same y value. Okay, so I have a y value now. And I have my entire coordinate, which is 4 and negative 1. So let's go back over to our graph and bring our vertex coordinate over. So our vertex coordinate, our vertex was at 4 and negative 1. Well, it's right on the axis of symmetry, so no, that's right, and it's at negative 1. So it's right here. Well, now that I have those 3 points, I know this is a parabola that's going to open upwards, because it has to go from here, and it has to go from here. So I know it's going to open upwards. Now that I've done that, I can tell if this is a max or minimum. Who knows what it's going to be? Minimum. This is the lowest point. Right here, this is the lowest that our parabola goes. If we go left to right, that's the lowest point it goes. So that's its minimum value. It doesn't go any lower. It'll go forever upwards. So now that I've graphed it, I can actually go back to my step, what did I say we're on, 3. And we know that our negative 1 that we found, this is going to be our minimum value. So our minimum is going to be this negative 1 value we found. That's our minimum value, and we'll put that over here just so we know. It's a min of negative 1. And finally, step 4. Okay, so our step 4, we said we have to find our y-intercept. In the note we took, we remembered that in order to find the y-intercept, we have to set our x values in either the standard form or the factored form equal to 0. So we just got to recopy our standard and factored form, which are right here. X squared minus 8x plus 15. So f at x, x squared minus 8x plus 15, or f at x equals x minus 3, x minus 5. So, like we said, our y-intercept, in order to solve it, we have to set the x's equal to 0. So, here are the x's here, and here are the x's here. I replace those with 0. Becomes 0 squared minus 8 times 0 plus 15. It's pretty straightforward. This will be 0, this will be 0. So our y-intercept apparently is at 15. Let's double check over here. 0 minus 3, 0 minus 5. I get negative 3, negative 5, positive 15. So again, I found that my y-intercept is positive 15. So let's go to the graph. Y-intercept is 15. So if I go all the way up here, it'd be somewhere here. When I'm graphing this, I know that this is going to hit the y-intercept somewhere over there. I just have to extend that line. Okay, guys? We extend it up there. That's everything from that page. That's everything from that page.